Hello, hello, hello. Good morning, good afternoon, good evening. Hello, wherever you are in the world. It's good to see you once again this wonderful week. This week, we're going to be exploring one of the new features of Cilium 116 that really triggered my imagination because I think it's just such a cool feature. We're going to be exploring packet drop events as presented by Cilium. And what that means is that if you've been using Kubernetes for a while, you'll understand the value of event data. So, like inside of a namespace where you're deploying an application, you can look at the events and you can see the image being pulled. You can see the image, the process being started up. You can see if there's like pull errors, like all that sort of stuff. And you would do that with the command kubectl get events. And it's even namespaced. You can look at events globally across the whole system, or you can look at events just for that particular namespace. Just kind of give you some insight into what's actually happening. And now with Cilium 116, it has the ability to emit events when there are packet drops. It's like if there's a policy drop, because there's a network policy that restricts the access that this application is trying to make, this can now be a part of the event stream within Kubernetes. I think that's just so cool. Anyway, as usual, let's go ahead and get started with a little bit of something else. Let's get started with our newsletter for the day, for the week. This is the newsletter that's located at cilium.io/newsletter. And if you would like to come and if you'd like to submit anything for it or actually be subscribed to it, this is how you would access it. You just go to cilium.io. Cilium.io/newsletter. And there you will see a way to subscribe. And then you'll also be able to see all of the historical ones that have come out. So this week's newsletter, what has it got for us? It's got about cloud native authentication feature, talking about how it works with Spiffy Inspire and how to try it out. We have a look inside the eBPF verifier, demystifying the CNI by writing one from scratch. That's pretty neat. I wonder how that relates to eBPF, because that's probably not. Oh, so Philippe is actually writing this as a blog post saying, like, here's how it actually works. Here's how container networking works. That's really cool. I saw this talk at Rejects in Paris, and I thought it was a really good talk. So definitely check this out. It's a great blog post. Awesome work, Philippe. Hello eBPF, a pure packet logger in pure Java using TC and XDP hooks. eBPF insights into real-time SSL and TLS traffic with less than 2 milliseconds of latency and 0.1% CPU load. That's probably going to be leveraging the TLS offload mechanisms. Pretty cool stuff. We have the Tracy agent being announced. So eBPF to monitor network requests between Docker containers and external hosts. eBPF map Prometheus exporter. Aqua Security releases Tracy Shark, which is a deep Linux runtime visibility meets Wireshark. I think that this is by OFAC. Okay. Not the thing I thought it was, but still pretty cool. Tracy Shark brings the world of Linux runtime security monitoring and advanced system tracing to the familiar and ubiquitous network landscape and network analysis tool Wireshark. Like Wireshark, Tracy Shark is a cross-platform tooling. Now events generated by Tracy can be analyzed interactively using, wow, that's neat, using Wireshark's advanced capabilities. So basically the event data is now consumable by Wireshark. That's pretty neat. I think I might want to check that out. It's really cool. In the ecosystem, we have a new case study by Cilium. We have a case study by Cacao. The eBPF security observability top tetragon use cases blog is out. Number 3 will really shock you. A case study from Schubert Phyllis. Lots of really great new content out there. In the how-to, integrating Dapper with Cilium, a sidecarless service mesh approach combined with a powerful distributed application runtime. Super cool. Enhancing OKE. Setting up Cilium networking on EKS without default add-ons. Talos Kubernetes with Proxmox using OpenTofu. And then in events, we actually just did this one, I think yesterday. It was called Simplify Kubernetes Operations with Cilium Ingress. That recording will be up soon. So if that's something you're interested in, definitely check it out. It was myself and Christopher. We did a whole presentation on all of that. Coming up on September 11th, there will be a new eBPF summit for 2024. The schedule is out, so if you'd like to check it out, this is what the schedule will look like. Have lots of great keynotes, lots of great talkers. We have Shweta coming to us with what would the world look like without eBPF. We'll get to hear from our awesome CTO, Mr. Thomas Graff. Then we have the CTF, which is to capture the flag. And if you haven't been a part of it, you should definitely check it out. The CTF is a really great way of exploring what's possible with eBPF. It's just really cool stuff, and it's always a very popular thing. We write our applications in eBPF, a tale from a telecom operator, end-to-end SCTP multi-homing with eBPF, Confluence multi-cloud journey to Cilium. There's a lot involved in that one, and I was pretty heavily involved in that process. That's been really a great thing to work on. Embracing NetKit across a million servers. What should we do? Implementing networking QoS for containers and eBPF by our friend Hemant. Ashish bringing to us adaptive routing with eBPF. Just lots of really great talks. It's all going to be a one-day event. There are lots of lightning talks and lots of great keynotes. So definitely come check it out if this is something of interest to you. It will be remote, so it will be actually broadcast from it'll be broadcast directly, and I'll be there hosting it for you. So I'll be one of your hosts, and I'll be joined by Liz Rice, who will be my co-host. And I'm really looking forward to this event. So if you haven't signed up, make sure you click this register button up here at the top and just come and be a part of it. It's really interactive too, because we have all of the guests who are actually making the presentations. Those guests are going to be live in the Slack chat, so you can actually ask them questions, provide them feedback, get more insights into what they're exploring, all of that great stuff. What is this? Registered already? Oh, I'm so glad. That's awesome. Yeah, it should be a really fun one. Looking forward to it a lot. And then we also have another Cilium eBPF day in Salt Lake. So if you're going to be there, that should also be a lot of fun. That's the newsletter for the week. There is a new and exciting Tetragon.io website. We just updated it. And up here at the top, it's one of my favorite features. If you want to join us in the monthly Tetragon community meeting, this is where you can learn more about how to do it. There's documentation on how to explore Tetragon, the use cases, the policy library, all of that stuff is still there. It's just a new change to the home page, kind of has a better community page, has a better lots of stuff. So definitely come check it out. If you have not explored Tetragon, there's lots of really great stuff in here on how to do it, including aggregating videos that are talking about it, event in a box, just lots of really great stuff. All right, next up, let's talk through this feature. I think this is a really cool feature, and I think it's going to be really fun to talk about and explore in this episode. So let's get started. So this is the CFP for the feature itself. This is actually a feature that developed and delivered and given to us by our open source community. A guy named Robin Elfrink. He wrote up, I'd like for Cilium to generate V1 events for packet drops related to pods. That means that when a pod actually sees a packet drop, I want to know that that happened. Currently getting information about packet drops requires access to Hubble, and I'd like to prevent my end users from being able to do that, but still give them information about errors in their network policies. So this is a really neat one because it doesn't actually require doesn't require access to Hubble anymore, because the event generator just basically kicks it up. As suggested by Roland on Slack, on decoded flow hook could be created that will emit V1 events whenever a packet is dropped, using some form of rate limiter to prevent hammering the API server. Really cool. So this is the original CFP, and this kind of just talks through like getting the design agreed on. And this is a pretty basic process within Cilium. So if you had some new feature in mind and you wanted to actually see about getting it done, this is actually how you would go about doing so. You would commit that CFP. This was committed in 2023 in November. And then after you did that, you could go ahead and implement that feature. So this is the PR with the feature implementation. Again, committed in December 2023, so a month after. And there's all of these pieces talking through like what it looks like for this to be your first contribution. And then if you wanted to see the code that actually implements this, there are 3 commits. We have add a Hubble drop event emitter to the Helm chart, and then we actually have the work that is on Hubble to add the option to emit V1 events related to pods on packet drop. And there are also tests written for all of this. And because the consumer is going to be Equinix NL, they added that to the users list, which I thought was pretty cool. And then finally, whenever we introduce a new feature, it's introduced as an alpha feature. So this particular feature that we're talking about, the V1 event emitter, that feature is in alpha. And we usually open an issue to determine like what the graduation criteria might be to actually move the feature to stable or to beta, etc. And so this is the issue on that. And as we work through this process, as we start kind of exploring it, if you want to provide feedback, then that feedback will help us be able to determine when we can move this feature to beta. So that is an overview of the feature. Let's go ahead and start exploring getting it installed. Oh, hold on. My PyCom died again. Oop. Much better. All right. Okay, delete cluster. Oh. Let's just ditch all of our clusters. Don't need anything stood up here. Okay, create cluster. Config. Okay. While that's booting up, I want to take a look at that configuration and make sure it is what I want. Okay, so what this does, this configuration here, will spin up a Kind cluster with 3 worker nodes and 1 control plane node. It has queue-proxy mode set to none, and it will disable the default CNI. And then I also have a registry mirror that is a pull-through cache for the for Docker cache, Quake cache, and GHCR cache. And I already have those running here. You can see those caches just running here, and that's a pull-through cache for those images. And that way, the first time I pull the image, it will actually just get cached, and then I'm able to feed the rest of those in without having to worry about it. Super nice. All right. So we got our cluster deployed. Cilium. Let's make a new directory. We'll call this events. And we will do Cilium install dry run Helm values. And what this will do is it will use Cilium to do discovery of the cluster itself and determine what the configuration should look like. So if I do that, I hit enter. I can see this is what the configuration looks like based on its discovery. So it will use IPAM mode Kubernetes. It has determined the Kubernetes service host and the service port, and it has configured kube-proxy replacement to be true. And that's because it determined that there is no kube-proxy deployed, so it would do that work. It's also determined there's only one controller or one control plane node, so it's set the replicas for the operator to 1. It's configured the routing mode to tunnel and configured the tunnel protocol to VXLAN. But there are a few pieces that it has not done, like it hasn't turned on the event emitter. So I want to do that. So let's take a look at the Helm chart Helm show values. Cilium version 1.16. Most recent 16. And we'll just pipe that to less. We'll look at emit. Okay, here we go. But here is the drop event emitter. It is by default enabled false. And then the reasons that the event would be dropped and how to make sure that it raises up for those particular reasons. There are 2 reasons: pre-configured, auth required, and policy denied. And then the interval between minimum time between emitting the same event would be 2 minutes. So every 2 minutes that will allow a duplicate event to be sent. Now the drop event emitter is actually a part of the Hubble configuration. That so let's go back to 1 here. And let's take a look at docs.cilium. Oops, wrong one. Docs.cilium.io as it made it into here. Drop event emitter. There we go. So this is the feature here. Hubble drop event interval, the reasons, and I suppose it would be just Hubble enabled. Okay, so for us to enable this in the install, there are a few things we need to configure. We need to basically configure enabled to be true, and we can let the rest of the defaults just be what they are without having to make any changes. We're also going to have to enable Hubble and Hubble. I think that may be the only thing we'd have to really make sure we enable. So that's very cool. So let's take a look and see if we can get this going. So what I'll do is I'll do Cilium install, dry run, Helm values, set Hubble what? Hubble drop event emitter. Copy. Enabled equals true. And let's see if that actually populates. Looks like it does. So it looks like Hubble, and that's good. And then we'll do set Hubble enabled equals true. Set Hubble relay dot enabled equals true. And passing these set arguments allows me to further configure the cluster, but it still retains all of the already learned configuration from the cluster. So this is me basically passing more arguments in to enable particular features that I care about, but that are beyond what would normally be turned on by the discovery. All right, so it looks like we got everything turned on here. So let's go ahead and apply that. So what I'll do, instead of doing dry run Helm values, and I could actually pass that as Helm values and just use Helm to do the install. In fact, let's do that. Let's try that out. So I'll pass the values to events values.yaml. And then let's go ahead and do our install. So we'll do helm install Cilium cube system, Cilium version 116.1 values.yaml. Let's see how this all shakes out. We'll do Cilium status wait. And what that will do is just sit here and it'll give you information, but it will wait until all things Cilium are deployed in a healthy state before releasing that connection. So it's really handy of having a way to wait for all of the deployment to work before moving on to other stuff. So now we're just waiting for all of these things to deploy. There's lots of ways to actually see this stuff happening. I could even be doing, let's do that. Let's do kubectl get events -n kube system -n. So here are the events that are happening inside of the kube system namespace. We can actually look all the way back in history. We can see like all of the events so far that are in the cache, right? So we're assigning Cilium to kind worker 2, we're pulling the image. We successfully pulled the image in 18 seconds, which is pretty quick. Now we're just waiting for things to get kicked off. Section kube system. Looks like Cilium Envoy is up now. Oh, look at that. We have a crash. What's happening there? Oh no. Well, that's entertainment. So what's happening here is that I have to restart my machine. Kind delete clusters all. How are we going to do that? Well, that's entertainment. So what I have to do is I have to restart my laptop because I just installed a new kernel, and the way that works is that it will actually remove from the file system those things that the kernel will dynamically load and provide new ones on the file system that the kernel doesn't need. So what I'm going to do here is I am going to pop open StreamYard on another device. And then I'll connect with that device briefly. And then what I'll do is I'll connect with that, and then I'll reboot my machine, and then I'll come back, and then we'll finish going through this process. So give me 1 second to make that all happen. Very surprising. 223. 682. All right, so now we're on my iPad, and I'm going to reboot this laptop. And we'll come right back and finish this up. Wild times. This goes to show once again, you do not want to upgrade your system right before you're using it, right? So my scenario was I didn't expect to have to, I wasn't anticipating that I would forget to reboot my laptop after doing the upgrade, and that was my problem. All right, machine is rebooted. Bear with me just a moment longer. All right, we're back on the laptop. Stream's still going. Let's get the rest of this figured out here. So, let me share my screen again. Present, share screen, entire screen. That one, share. All right, CD events. Kind create cluster config. And kind mn no KPR. Oh, KPR. Let's give that a moment to go. And we'll do our install again, and then we should be good to go. Surprising surprise, like I thought I had that all ready to go, and I missed it, so my apology. All right, there we go. So now we can do kubectl get all namespaces. We can see things are working all right. CoreDNS is not deployed yet, so let's do helm install Cilium. Boop. And then we'll do kubectl get events and kube system w. Scroll this up a little bit so we can see a little better. Created container config, started container config, pulled the image. Waiting for things to get started up here. Okay, things are starting to slow down a little bit, which means things are clearing. Let's go ahead and split this vertically and do kubectl get pods system. Let's see, things are actually stabilizing. Oh, looks like we do. Do we restart again? One second, code system. Oh, all right. What happened this time was, I remember how we generated a values file. Let's take a look at the difference between these two. Let's see, kind create. This will be entertaining. So new kind cluster. What's happening here was it was failing to actually interact with the API server. And that's partially because the IP address of the API server changed from the time when I generated the config against the cluster that I had created previously and the time that the cluster was currently installed. Because you never know what IP address the control plane or the API server is going to get. So this is why it's actually really good just to regenerate the values. But I wanted to show you that change, right? So if I generate a values 2, and I do a vim diff of values diaml and values 2 diaml, you can see the IP address, and only the IP address has changed, right? Everything else in the config that we had enabled is still there, but the IP address changed. So that's fine. Just something to be aware of. So we'll do helm install Cilium, and we'll change our values file to values 2. And just to clean it up, we'll do rm start AL. Okay. Do our watch here. Looks like we're making better progress. Watching our events. Oh, funny. You see that both of my core DNS pods actually landed on the same node. They landed on kind control plane. Hubble UI and Hubble Relay both successfully deployed. So now if I do kubectl get pods, I can see core DNS is happening, Hubble Relay and Hubble UI are happening. It's all good now. So now if I do kubectl get pods -n kube system -l case app equals kube DNS, dash O wide. This is what I was talking about before. It looks like they both deployed to the kind control plane. And if I saw a really cool feature of the kubectl command line, if I do kubectl rollout restart, deployment dash n kube system core DNS, what do you think will happen? The restart basically just means schedule new pods. Don't change anything else about it. Just restart them. And now we can see that we're deployed across multiple nodes. It's kind of neat. All right, so it looks like we've got everything deployed here. We see any events in the default namespace. Cool. kubectl create ns test. We should see no events in the test namespace. So let's create some pods there, right? So let's do kubectl create deployment dash n test. We will set up an echo server. Just change our namespace to the test namespace. Look at pods. See it running. Kubectl scale deployment echo. Echoes 5. Get pods dash show labels. So we have app echo and it's been deployed. Now let's go ahead and deploy a NetShoot. Kubectl run it image equals go laka NetShoot. Now this creates basically a running shell container that we can connect into and interact with. And it also sets the labels to app NetShoot, which makes it super easy for us to interact with it. So let me exit out of this. If I do kubectl get pods, I can see I have my bash process. If I do kubectl get pods dash show labels, I have a label set app equals NetShoot and app equals echo. Why did it get called bash? Did I call it that? No. I forgot to give it a name. So it picked bash. That's fine. execti bash VSH. If I do curl echo, oh, I didn't expose the service. kubectl expose deployment echo. And it'll just default to cluster IP, and that'll be fine for us. Curl echo test svc. Is it the other way around? No. Namespace service. go. Oh, maybe it just wasn't up yet because it's pulling the interesting. So we can see that now happening. Let's go ahead and mute that, and we'll split this one. Let's take a look at get events -n test -w. So here is all of our startup. We see that's currently event set. And now the way that we've configured the emitter, it should only emit events on things that fail. So that's all fine. Let's do one more split here. We'll do Hubble observe -n test -f. Oh, Cilium Hubble port forward. Okay, now if I do my curl again, I can see the event go by. There it is, right? There's my curl to the cube DNS. There's all of that data going back and forth between the two sides. We see all of that. So next up we want to do is we want to create a network policy that will not allow the bash container to talk to the eCHO server. So one way to do that, lots of ways to do that, but one of my favorite ones is to go, let's see, let's go put a 5 here, open up a new website. I think you've all seen this, but if you haven't, it's just a great way to learn about network policy and to also dynamically create network policy. So if you go to networkpolicy.io, this is a website that is hosted by the Cilium community. And inside of here, you can see policy editor, you can see policy repo, etc. So I want to say try network policy start. And what I want to do is I want to, inside of the network namespace, so policy name will be drop allow port 80. The namespace will be the test namespace. The endpoint selector will be app equals bash. Save. And then I want to I don't need this rule, so I'm going to delete it. I'll allow cube system. I'm not going to allow everything in the cluster, though. I'm going to allow a specific pod. Equals echo on port 80. Now, this is the tricky part of this, because this selector will actually only allow traffic on port 80, and the actual echo server is only listening on port 8080. So this whole policy basically allows my application, my bash application, or the shell that we created, to interact with kube DNS. It's awesome. We have a match pattern, so we will see those DNS requests. And then we have 2 endpoints match label app echo, 2 ports, port 80. And that will actually break the network connectivity because it's not listening on port 80. It's listening on port 8080. So let's pop back over here and try to apply that. The events at netpol YAML, paste that in, Control D, cat. Looks like it all applied cleanly, so we'll do kubectl apply-f. Actually, so that still works. And then if I do netpol, I'm going to try again. So get Cilium network policy. Oh, dash OEM. Policy validation succeeded. That's a new feature. Oh, this is an and. You see they both at the same depth. 2 match labels app echo and 2 ports, port 80. That's why it's failing. That call. So if I change this to 2 endpoints app, nothing. Get all delete dash F Nepal. Get all apply dash F Nepal. So then if I do this, so I'm setting 2 endpoints queue system, allow rules DNS match pattern. Egress to that on port 53. Why is that being allowed? What in the world is happening? 2 endpoints. Match labels app nothing. Endpoint selector match labels app bash. So this should actually be effectively a deny for anything that isn't app nothing. That's neat. What am I missing? Oh, network policy. Are you taking me for a ride? Oh, let's see. We're overthinking it. Let's do this. What we're going to do is we're going to actually enable just a cluster-wide network policy that will drop all traffic except for DNS traffic across the cluster. So we'll just go ahead and do that. Kernel delete Cilium network policy. So put in this default policy, and then if I try to actually chat again, there we go. We got our traffic drop. And here's the information that actually shows up, right? Outgoing packet dropped, policy denied, to test echo, and then the pod that we're actually connecting to, and then the IP address, and then TCP port 8080. And if I try it again, it won't happen right away. Although I still see the event in Hubble, I don't see the event populating up into the Kubernetes events. And that's because there is a mechanism in there to throttle the number of events that we see. So after 120 seconds, I should be able to see another one. And there we go. So after 2 minutes, I definitely saw another connection happen. So let's do this. Let's do every 1 second, little timeout. And we can see the DNS request and the resolution of it. So even though I have access to Hubble and I can see it, this event is now just available to anybody with the ability to see events inside of their namespace. And that's the cool part about the feature, is that while it is super valuable that you be able to see this from Hubble's perspective, if what you're trying to do is also just make it so that people using a namespace are able to see that, you can actually also tweak that star. Now there is one more thing which is pretty neat. So this is configurable. It doesn't have to be 2 minutes. So let's see, Cilium config view. Let's take a look at the timeout or the interval for the. See that Hubble drop events interval is 2 minutes. I want to set that to something much smaller. Let's do Cilium config set Hubble drop events. And let's set that to 10. I'll restart the Cilium pods. Now we see a limit of 10 seconds. Okay, so we're seeing a lot more spam, but we're actually also seeing it go back and forth between different endpoints because I'm spamming it every second. So every 10 seconds, a new event will pop. Actually, that's less than the 10 seconds. So I guess it's like 10 milliseconds because maybe that's how it actually evaluates to time without some setter. We haven't labeled our batch pod. We did actually. I'm not sure why that policy. I think I was actually just accidentally allowing that traffic because it was app. But there we go. That's the new event wrapper, and I really like it. It's actually configurable to some degree, and I like that it actually notifies folks. And so you have the ability to configure the interval for it. You have the ability to see the packet in both Hubble and also now in Kubernetes events. So neat stuff. Anyway, I hope that was useful. If you are interested in exploring this feature yourself, or if there's something that you want to see more of, definitely let us know. If it is a feature that you do end up using, definitely reach out in that CFP for beta and give feedback on it if you end up using it. I think that's all I had to share with you today. I hope you have the best weekend of your life. I'm going to spend some time at the Exploratorium this weekend, so that should be super fun. So thanks again for tuning in. We'll see you all next time. Have a great, great weekend. See you later.